So you walk into the customer's home and they say that the AC was working just fine yesterday, but now it only blows warm or room temperature air. So I confirm what Mrs. Jones has told me. There is room temperature air coming out of the supply vents. This lets me know that the blower is running, so I don't start checking anything there yet. The next thing I want to do is head to the outdoor unit and check to see if it's running. Before going anywhere, check at the contactor to see if anything is shorted to ground. You can do this by putting your meter setting on continuity check. Put 1 meter lead on the left terminal on the load side of the contactor, and one of them to ground. Do you have any continuity there? Try the other load terminal to ground. Do you have any continuity there? If you have continuity at either of these terminals to ground, then something downstream is shorted to ground. Now you just have to find it. It could be any of the high voltage wiring, the contactor, the capacitor or start capacitor, the condenser fan motor, or the crankcase heater. Let's ohm out the compressor first. I usually just do this with the wires at the service panel still connected to the compressor. If I see something screwy, then I'll make an effort to actually go in and check the terminals themselves at the compressor. I try to stay away from the compressor lugs themselves because those terminals can actually blow out. There's a few hundred PSI of refrigerant behind those terminals, and if they were to blow off while you're in front of them, they could blow right through your hand, chest, or face. So if I don't have to go there first, I don't. Get your wires that lead to the compressor together. Check your ohms reading between common and start, common and run, and start to run. Without going crazy in depth on this video, generally you're going to see the resistance between common and start will be a little bit higher than common to run. The total of those two numbers is what you'll read between start and run. So if you had 2.3 ohms between common and start and 1.7 between common and run, then you should have about 4 ohms between start and run. If common to start and start to run is OL, then you have an open start winding. Same on the other side. If common to run is OL and run to start is OL, you have an open run winding. I'm trying to stress the and here because if you have OL between start and common, but when you test between start and run, it's not open, it's likely it's just the internal overload switch that's open. Let the compressor cool off and retest it before condemning the compressor. You'd hate to charge a customer for a bad compressor when it was just overheated due to another issue. When the windings on the compressor are defective though, the hermetic compressor will need to be replaced. Hermetic compressors, like the ones that we work on in residential HVAC, are sealed, so we can't get into them to make any repairs. So what if the windings are good? Go check the breaker at the main panel. A breaker has 3 positions: on, off, and tripped. Is it tripped to the middle position? Try resetting the breaker by flipping it to off and then back to on again. Breakers trip due to heat and excessive tripping. Resistance is a source of heat. High current is a source of heat. Hot outdoor temperatures beating down on the southwest side of the house can be a big source of direct heat to the breakers inside the panel. If the breaker trips immediately, you've got an electrical short to ground somewhere. If the breaker trips after running for anything longer than immediately, you could have excessive current, too small of a breaker or fuse, high indoor return air on a scorching hot day, which will put a ton of stress on the outdoor unit. A dirty condenser coil. If an outdoor unit can't draw air in across its coil, it'll overheat the AC. A breaker that trips several times can get weaker and weaker until it takes less heat to trip it. So that's a possibility to keep in mind. If the breaker's not tripped, turn it off and check the fuses at the disconnect. After checking for no voltage, since I just turned the breaker off, I always remove the fuses to check continuity between each end of the fuse. If either of them is OL, it's done its job and protected the circuit, but it's also the reason that the AC isn't starting. Should we just replace the fuse or reset the breaker and move on to our next call? No way! As an HVAC technician, aren't you dying to find out why the breaker is tripping? Maybe it's a locked rotor. A locked rotor most commonly happens at the beginning of the season when it hasn't been running for a while. If you hear the compressor is trying to run, but it's not pumping anything, it could be stuck. Put an amp clamp on the common wire while it's trying to start. You'll see the amps skyrocket beyond its LRA. In this instance, I let the customer know that I want to try a hard start kit to see if it'll give it that extra little kick it needs to get going. If it doesn't work, I'll take the start kit back. But if it does work, they'll need to buy the start kit from us. And at that point, they just need to understand that their compressor is on borrowed time. Something that you can check next is the line voltage at the contactor's load side. Of course, this is with a call for cooling at the thermostat. Suppose your 240 volt system reduces to less than 200 volts when it's trying to turn on. Figure out what's going on there. Is it the wire size, a bad contactor, a bad wire between the contactor and the compressor terminal? But if these are good, let's move on to the next step. Let's try bypassing the compressor. Another thing that you can try is removing the wires from the compressor altogether and just run the outdoor unit with the fan only. If the fan works, great, you can move on. You know it's not the fan tripping the breaker. If the fan isn't working, troubleshoot it. You may have to replace the fan motor, cool down the compressor until the unit's ready to run again, and retest the system. Rarely do I ever find that the condenser fan motor and the compressor will have gone bad on the same day, but I guess it can happen. Next, let's talk about internal overload. Let's assume that we do have good power to the condenser's contactor and onto the fan motor and compressor, but the compressor's not working. You can tell that the fan works because it's spinning just fine and even has good amp draws. Let's check and make sure that the compressor hasn't overheated and shut down on internal overload before we condemn this thing. Check the resistance by switching the meter to ohms, and check between the common and start winding, and then do the same with the common and run windings. Does the meter show an open circuit on either one of those tests, but not between the start and run terminals? If so, we should let the compressor cool down and retest it. Letting a compressor cool down on a 100-degree day can take a long time. I like to use a garden hose to pour cool water over its top and then let it run down the sides of it evenly. There's literally a switch inside of that compressor that will open or close depending on whether it's safe to run or not. Kind of like a self-destruct prevention switch. So why did the compressor internal overload switch open in the first place? A bad capacitor or a hard start kit can cause those compressor windings to overheat or just not start at all. So before we diagnose a bad compressor, we should make sure that our capacitors are good. Something that tricked me one time was a bad start kit. I called another tech that I worked with and they told me to try bypassing the start kit by removing it from the circuit. Guess what? The compressor started and I haven't heard from that customer again. Bad valves. Are you sure? Something I hear a technician say a lot is that the compressor has bad valves. Well, today's scroll compressors don't have valves. They do have bearings that can go bad, but valves were an issue with reciprocating compressors in earlier models. If you have decent refrigerant levels, but the compressor has problems starting and running efficiently, a lot of vibration, or a metal clanking noise, you could have damaged bearings on the compressor. It's caused by refrigerant wearing out the oil, creating a situation where copper plating occurs. From there, the compressor overheats and draws higher amperage. Remember, you're going to see higher amp draws on a compressor the hotter it gets outside, but if a compressor is running anywhere near its RLA and the refrigerant charge is good, that compressor is hurting. If any of this sounds like what's going on with the compressor that you're working on, it could have bad bearings, not bad valves. Some other things to check. So many things can happen to a compressor to cause it to fail. Not only do you have to diagnose that it's a bad compressor, but you also have to figure out why it's not working. Things like contaminated refrigerant. The only thing that should be inside the refrigerant lines are oil and virgin refrigerant. If moisture, air, dust, or anything else gets inside, the lines will become contaminated. Contaminated refrigerant will become acidic over time and eat away at the protective coating on the stator windings that make the compressor rotor spin. Once the protective lining has been deteriorated, the copper windings will become exposed and fail in a big way. This creates a situation where the compressor shorts directly to ground. A wire has now created continuity with the compressor's body and completely burns and chars anything inside of it. The oil, refrigerant, and the compressor's components will all become black and lined with soot. Burnt wiring. If the terminals attached to the compressor are burnt or barely intact, you can imagine the arcing that occurs across the gap of those loosely stranded wires. And that arcing creates an intense amount of current, which creates a ton of heat. Replace the wires and retest the system. Incorrect sizing of equipment or refrigerant lines can create an unbalanced system. If the indoor evaporator coil isn't large enough, liquid floodback can happen, causing an enormous amount of stress on the compressor. Is the line set too long? There are maximum lengths of the refrigerant lines listed in the installation manuals for a reason. Does the copper line set go under a sidewalk or under the ground to make a big dip in the refrigerant flow? This can create a situation where there's a ton of liquid refrigerant stuck inside the lines right there and cause startup issues. Kinks in the line set. Any sort of restriction, even a stuck TXV, can cause unbalanced pressures during startup. And the last thing that I can think of is an overcharged system that can cause a lot of stress and locked rotor amps that are super high, preventing the compressor from starting normally. Removing some refrigerant will alleviate some of the pressure. Sometimes it's just best to remove it all and start with a fresh charge so that you, the technician, know how much is in there now. This helps make the diagnostic easier because you have more information. Thanks so much for watching, and we'll see you on the next video.